Hi, welcome back to PBH 212. This is week 2, and this is the third part of this week presentation. Again, make sure you check your syllabus. You're probably sick of me saying it, but you gotta hear me say it a lot of times. Check your syllabus. Just make sure that nothing has changed. After a while, just get used to doing it, and you'll be fine. You do have deliverables due. As well. There's another quiz that you're going to be responsible for, and there's another posting that you're going to be doing a little bit more relevant than the first one. I think it's a little more, that was more general, but this won't be. All right. And again, the quiz only has one try this time, so we've had our two try one. We're not going to do that again. So I think you guys can handle it. They're not that hard, and I think you've seen what's involved in doing them. Okay. So we're going to move on to chapter 8, and let's see what we're going to talk about standards, which is really an important part of all information systems, period. Never mind public health, clinical, all of them, they all have to follow standards. It's important, just like anything else. It's a language, and we'll get into that as we go. So the objectives in chapter 8 are understanding of the processes of standards and content standards. So they're a little different, but they both are standards. The benefits of standards use and the obstacles to adoption with any standard in any business or model. Standards used in public health systems, general processes for standards development, and a review in some details about the 3 commonly used standards in public health, HL7, LOANC, and SNOMED CT. Okay, so public health systems use standards. Okay, and during this, we're going to, when we do this chapter, we're going to use a lot of examples that have to do with laboratory reporting because it's easier to relate to, I think, especially in public health. A lot of triggers happen from that, and we used them as examples before, so I'm going to continue that as we go along. So communicable disease reporting and surveillance of emergency department is another one. Those are different standards. Emergency medical services, EMS, pharmacy over-the-counter, OTC, and poison control data, air and water control testing, data sharing with private and public entities and programs. These all use system standards. So let's talk about the electronic data interchange makes this necessary. So what that involves is there's a large range of communicable disease reporting from labs. So if you want to do any kind of data exchange between systems, you need some kind of a common standard in order to say, I can move a piece of data from this database to another one, or I can make this data available to your program and it will understand what it is. So when it goes to look for it, it's not trying to figure out, okay, where is this thing? If you've ever seen a database like an Excel spreadsheet, some of them, they're enormous. They go on and on and on. And I'm just saying spreadsheet because that's usually how most people see databases unless you've worked with them. They can be very big, which can slow them down too in their search patterns. So there's some subsets, there are screens and all these filters and things like that. So in all of that work, we need to come up with a set of standards that make it simpler to do this. So communicable diseases are one of them, and that uses electronic laboratory reporting, or ELR. So there's a wide range of surveillance sources available, right? So we have to be careful about how we get that data from each one and where we can use them. So surveillance systems really are kind of allude back to what we talked about. There's like the emergency department, right? EMS. Medical services, emergency medical, there's pharmacy, over-the-counter, the poison control thing we mentioned, and absenteeism data that we also get. There's interoperability issues that come up also when you work with this stuff. So part of that is you want to follow a standard that's been developed. It's called the ISA. And you may never have heard this before, but it has a wide-ranging oversight, way beyond just health stuff. So part of this is just trying to make sure that we all meet these standards. So the National Coordinator for Health Information Technology, that's the ONC. I know we have a lot of acronyms in this class, so bear with me. Coordinates healthcare interoperability standards and implements them. So meaningful use, which is something we've talked about a little bit, right? That was a bill that was passed by Congress and had funding, identified that incentive programs were needed to help promote the adoption of electronic health record systems, right? So part of this is surveillance and electronic lab reporting data. And so data sharing and exchange within states and between state partners was part of this initiative. We really wanted to promote the data sharing and exchange. So how do you get it? First, you have to get everybody on some kind of a technology to talk, right? Which we discussed a little bit. But now that you have it, everybody has to talk in the same language, or you're going to have the Tower of Babel, which is basically no one understands anyone. Or it takes a lot of work to do that, especially when we discussed this idea of breaking down silos and creating a very flat plane of information. So for informaticists, this can be a challenge sometimes, but having these standards helps a lot. So functional requirements in design, differences may be based on function, right? They can be based on like case managers versus the function of population surveillance. So what can that mean to us? So we have really kind of three main causes of non-communication. And that's one of the ones I'm talking about, functional requirements. Maybe there's some functional requirements in one silo. I shouldn't call them silos, but when a function application, like the two I just talked about, that are going to not align with another one. They don't quite go together. And then there's also policy requirements. So there are some policy requirements that restrict what you can use for software. They're actually part of either a policy internally within a department or an entity. So it's important to understand the ramifications of that. And then there is external restrictions too, which are imposed by federal funding. There are some things that they won't support in the funding. A current example is the enhanced, some of them are single siloed. They have to be like HIV AIDS reporting system, EHARS. So it's browser based and it's used by state and local, but it's a separate thing. It's not as interoperably allowed as some of the others. So we sort of have these standards, but we also have legislation and other things that are restrictive in the space. So again, not all systems have achieved this goal. Additional causes of public health silos are both closely tied to standards. So system architecture, more specifically, the lack of it. Sometimes these are ad hoc systems. They've just kind of grown out of necessity. Oh, we need more storage. Oh, we need this. Oh, we need that. But there's no overarching blueprint we discussed before. And without a system architecture, this is really difficult to do. You're going to end up with a lot of ECTs that don't work together, which is the other thing we talked about. You need the system architecture as the overarching blueprint. When you don't have one, it's really hard. And then exchange partner variations. So this is kind of a problem. It's inherent in public health matters. Trying to ask all these partners to agree on and incorporate any choosing standard, it's formidable. A lot of places like to have their own standards because then it prevents you from using another type of a vendor or something else. It's inherent in their marketing. They don't want that to happen. But as more entities are entering into this area now, it's becoming more and more clear that that's not going to work anymore. And so that everybody's sort of relinquishing those things. I mean, there's a system proprietary aspect, obviously, but interoperability really needs to happen. And that's coming from languages too, like Java and stuff like that. So that's really changing the landscape. So in a nutshell, implementation of standards, it's hard. So although, like, here's an example that was in your book, and I laughed when I read it, but it's so true. Although the metric system was introduced in France in 1799, the United States today is the only industrialized country that does not utilize it as its official standard. We do use it, we do recognize it, but we don't use it as our standard. We still use our own. So that just shows you about independence of nations and things like that. And you get that in the States too. So it's not so simple to do this. Everybody has a stake in the game. They don't want to lose it. There must be agreement among all the stakeholders, which is kind of what I was getting to. So system architecture, and again, more or less the lack of it, right? It's the importance of having system integration architecture. It has to be known or discontinue when building a new system. Then the outcome might be an isolated one, right? So you have to have an agreement. It can be challenging. If the groups or industries are fragmented, it's hard to get them together because now we're talking about a large, industry infrastructure too that public health depends upon. How do you get all these guys lined up? So a lot of times they kind of have to be corralled by law, which is not a good way to do things, but sometimes that's what has to happen. And then you have this issue of experts often disagree on details. So when you take your classes on research in theory, one of the things you're going to find out is that expert opinion is the weakest form of evidence. And there's many of them, and that's why it is, because they conflict. It's just what I think. And so if you have somebody in a respected area who's been doing something a long time, they may tell you something that somebody else who is in a similar role may disagree with that. And they may have their own viewpoints, but that's part of learning. So how do we deal with that? That can be hard to do. Justification, that's the other thing. So now it always worked. Why do we have to move to this? How can I get other people to fund it? Public health is dependent on tax dollars, right? So it's not self-generating income. We have to get it from somewhere. You have to really make that case to the folks that control the purse strings. Why do we need to have that? Why do we need to do it? How is it going to help? So there's always difficulties for the exchange of data or utilization aggregate data from many institutions. Pardon me. So that's always going to be inherent, no matter what you do. There's always going to be some utilization data problem where one part doesn't quite fit right. And those are always challenges that are ongoing. But when you're first starting, it's very, very difficult. So standards are developed by a panel of experts and formally approved by a standards development organization, the SDO. And currently, there's a couple of them. One of them is the International Organization for Standards, ISO. I think some of you may be familiar with that. Those are used a lot in business world, and they do a lot of standards, not just that. And then there's the American National Standards Institute, ANSI, which is probably known to a lot of other people. It's just really dependent on which part of the world you come from as far as work. But the main thing is, in practice, many standards are products also of legacy. So they're used within an industry or group because they're a local best practice. So sometimes, even though we have these large organizations, as the two I mentioned before, who are controlling standards, they don't have a standard for everything. Or there's a new development or a new technology, or there's a gray area in something where you're doing it. How do you quite figure that out? So those are kind of de facto standards that kind of go along with a practice. But they can be really useful when there is no formal standard available because it, in fact, is a created standard. So people can follow it. And that's not a bad thing. So the ISO process, this is worth discussing. So how does something become a process, right? So the International Organization for Standards, they follow a 6-step process on how to develop a standard. So the first one is they propose to the appropriate technical committee. There's a number of technical committees depending on what you're trying to propose a standard for. And you have to know about the right one, but if you're involved in this, you would. And you make a proposal to them. And then a working draft is generated that comes from this. So this is developed by a group of experts that's part of the assignment from the technical committee. Oftentimes, when you get into a practice of something you'd be asked to weigh in on stuff. And I do get asked by different organizations I belong to occasionally to, can you be part of a committee? Or, hey, we're looking for people to volunteer or help with certain things. And these are all the subject matter experts we're looking for. Which ones do you fit into? And you basically go through that exercise and then you become part of this group. And that's what you're asked to do. It's like, look at this and see, do we have something that can work for this? That they have evidence for. They go out and research it. They work with the people that proposed it, and then once they have a draft, they share that with that technical committee. And then the draft is, and then if they say, "Yep, this is great, looks good, meets all the criteria," they'll send that out to all the ISO national members and say, "Here's a new draft on this proposal. We're looking for input," and there'll be feedback generated because of that. And then probably adjustments will be made from the feedback by the TC and the expert group. And then a final draft is sent to all the members for a vote. And then it becomes an official ISO international standard if the vote passes it. And I don't know what the threshold of the vote is, if it's 2/3 or majority, I don't know. But then it becomes an ISO international standard. And then we have something. But obviously there's more hurdles than just that. Agreeing on a standard is only the start of the journey. Not all partners in a data exchange may share equally in those benefits. And I did mention a few before, but we're going to get into a couple before next. Implementation and utilization of standards is often very resource intensive. If you've been doing something a certain way and you decide you want to adapt a new ISO standard, let's say, it could be a huge amount of work to get sign off on that, especially if it's something where it requires oversight by someone else to say, yep, you meet the standard. Because a lot of that happens in this world. You decide to do it and you build your stuff to what you want to get certified because that makes you more desirable to the buyers or whatever. So in the world of public health, you're going to want to have your standards vendors that are all approved and certified because that means that it's interoperable with other certified standard vendors. So that's kind of an important thing to think about. Implementations are borne by partners who may not share in the benefits. So we're going to get into an example of that in a minute. I did mention one early in the last presentation. Decisions to develop, select, and implement or require standards should not be reached without careful consideration. Do your due diligence. It is so important. Planning is probably the most important aspect of doing any of this because once you make a commitment and you start to go down the road and you find you've gone off the track, it's very expensive in time and resources to get it back where you want, or you're going to finish with something that's going to be a little off and it's going to be a Herculean effort to change it. And that's where a lot of people get stuck with these things. So let's look at electronic laboratory reporting. This is a big one in this space, and this is the example I used before. So around 2000 or so, public health started asking labs to legally required, they make them required, to send reports on conditions of public health, including hospital, private, and public health labs, all labs. They handle health data, to report electronically through a new institution of an electronic health laboratory reporting tool. So those systems were created because they obviously create, faster access to data, which is great, right? Except what happened is they must be submitted standardized in both format and content. So it wasn't just, oh, you have to report them through this new system. Oh, you have to change how you present your data. So maybe my data needs a dot in front of it or a dash or an @ sign, or some other form of a delimiter, quote unquote, to separate the values or something like that. And you're going to see what this looks like in a little bit. And that sounds like it's simple, but it's not. If your software works a certain way and now you have to present it that way, that means you have to run it through another piece of software to clean up your data and make it acceptable for me to see. And then you have to post it into my system. And sometimes that's referred to as middleware, but it is a lot of expense to put on a company to do that because it can be a major piece of work. And this created significant expense for all those laboratories. And the laboratories use the information system, LIS, so there was no direct benefit for them to do this. So when they did it, some funding for meaningful use was available, but most of this work was funded by the laboratories themselves. So basically, the way it worked is a law was passed, you have to do this, and now the labs had to spend their own money to get on the standard. Either that or they couldn't do it. We wouldn't be able to work in the healthcare world. They would not be reimbursed by CMS or probably any private payer, because once CMS makes a decision like this, the Centers for Medicare Services, since they're the biggest player in the payer space, the others follow them. So because they see some value in doing that. So the effective contemplation of a standards issue, this is kind of how you work in a decision process flow for standardized utilization. This is in your book. It's a very simplistic one, but it's a good one. So you're really starting with the data from an internal or external partner. Data exists in a standardized form. If you say yes, then it's reasonably postured to require usage. You can say yes, and then you can implement the standard. It goes right over there. It's really easy, right? But what if it's no in the beginning at that decision diamond? Then does the standard exist? You say no. Does the de facto standard exist? No. Then you have to either accept non-standard data or you have to get it changed. And that's where all this expense comes in. So this is kind of a realistic view of walking through a very simple decision tree on how things need to happen. Software operates in the same way because it makes decisions about what it sees and what to do next. So these are logic charts, and they're really important to look at process flow when you're designing something even at a high level and you get down to really small nitty-gritty things. This is sort of how it starts out. And so let's take a look at some of the information technology standards. So there's different data standards, as we discussed a few of them. So there's vocabularies and terminologies like LUNIC and SNOMED CT. There's reference information models such as HL7, right? They have a reference information model called RIM. There's message-based and structural things that HL7 supports. Identifiers such as the National Provider Identifier, API. There are privacy standards about access and control. There's work process ones, workflow, data models, internet standards, transport mechanisms, and there's many more. So you can see how complex they get. So standards really kind of fall into two fundamental categories, which I mentioned in the very beginning. There's a process standard. This has to do with procedure and policy standards that your organization follows and that others will follow. And then there's the data or content standards, and this has to do with what your data looks like. So common terms, methods, interoperability, and integration. And this really is important when you start to talk about vocabulary, format, and transmission standards, because you need to move data around. It's important for researchers to have data that matches, and a lot of this ends up in that kind of world. So it could be researched in a way to find out how to produce a dashboard or a best practice, and it's really something you want to follow because it gets very difficult when your data gets way outside those ranges. It's tough, and so we need to keep those things in mind. So let's look at privacy and confidentiality. So this generally refers to in a people context. So it's a state of being free from unauthorized intrusion or invasion. So if you think about this concept, it's applicable to medical records because it's a person's own residence, right? It's the same. It's their information. It should not be shared without their permission. The only reason that a health provider is able to see this or gather it is to treat the individual. Even within an institution, it's not legal for another provider just to go look up somebody's health record and see what's in there just because they have a title or they have access to it. No, it's not. You have to be involved in the care of the patient. And when you're not, you're out of the record. You're only in it when you need to be. So if I was a nurse practicing at Yale New Haven and I had a patient on my floor and I was dealing with something with them, I would have access to that record while I was caring for them. And when they moved out of my unit or they were out of my scope, I would stop having access to that record. There's no reason for it, even though I could look it up. I shouldn't be, and that is tracked. So it's not that way. In the public health domain, it's the same way, even though more information is more readily available in public health domain, because you do need to know who people are and where they live and things like that. It's also very private and very protected. So when you move data around in a system where all of it's available in the public health arena, how do you figure out who gets what? Maybe they don't need that information. So if they don't need it, they shouldn't see it. And that's part of what this is about. So confidentiality is viewed in more the context of information. It usually deals with accessing and sharing information and data, and also what you should be sharing. So privacy and confidentiality. So you need data integrity, and that's really important. That's the freedom from errors and flaws, right? And data confidentiality, and that's the thing about making sure your stuff is secure and it's private. Those are really kind of a prime focus of security on most systems. Data integrity needs to be maintained for a transaction. So if I pick up some data and I move it from A to B or I make it available, it shouldn't change. Because if it does, it's not going to be reflective of the source I got it from. So that's integrity, right? It's got to be the same. And that's why standards are so important and why we need to work in them so that we don't have that problem. Because there's like the title of that movie, Lost in Translation. It can happen. It only makes a little bit of a change in the word I use or the data point I produce that can make a big difference in how that data is looked at. So that's important, right? Data confidentiality is a critical concern in public health, which frequently requires the exchange of clinical and laboratory data containing patient identifiable information. In the public health domain, there's really a lot of that because it's part of the right protecting the public. It kind of supersedes privacy, but that's only in the context of using it. It's got nothing to do with what you show to the general public. That's a whole different realm. And so you can't really do that. And so part of that is to de-identify that data. So if it's used for research, names, addresses, unless you really got to know them, they're removed from all of that. You never get seen in a study. You see like it might be a pseudonym or a number system that's put in place, patient number 2, patient number 3, and it goes on and on and on. The problem that becomes with this that is worth discussing here is that we also live in a time where there's a lot of health disparity between different populations. And unless we are willing to identify those populations either by belief, race, or etc., it's very difficult to treat that issue. And so that's becoming a problem right now in the data world. So how are we doing that? How do we actually show that so that people understand that the public health is trustworthy as a government agency and that the work is trustworthy? So we need to deal with those too. There's enterprise security, which is the global security. Physical security measures, those are things like locks, biomedical scans, etc. I just read an article about biometric, I meant to say, security measures where you do fingerprint scans or eye scans. Fingerprint scanning on a lot of devices that work at home or for locks and things, they are devices that don't actually store the fingerprint information internally in an encrypted area. They use some other Wi-Fi verification method, and they are open to hacking. As a matter of fact, it's a pretty easy hack, which is really ridiculous considering you think you're using your fingerprint, nobody else can get in there. Well, they can. So we have to be very mindful of those kinds of things as informaticists too when we work with our IT partners. Administrative measures, and those have to do with who has to get what data, and I need to administer all this data, which is in a secure, encrypted way. How do I make sure the data is right? How do I make sure the data didn't get corrupted? All that. So those are all things we need to think about. And technical measures, how do we ensure that systems are redundant and that they're secure from hacking or being ransomware in a company, right? So there's a law that a lot of people are pretty familiar with, or a term they've heard, and that's HIPAA. It's the Health Insurance Portability and Accountability Act. It was passed in 1996, and its origin really has to do with the fact that insurance companies at the time, it was legal for them to share health information across services. for instance, would be I own your medical record. I find out you have cancer. I share that with my life insurance part of my company, and they cancel your policy. That kind of stuff. And that went on for a while. It was also used as marketing opportunity to say, hey, you know what, this person would be a great fit for this thing because, they need this or they need that. They're really good health. Let's go after them for this. And that's what they would do. And so you can't do that. That's like using your health information without permission. So it became a legal act to protect your privacy. And that's where that started from. But HIPAA itself is very broad based, and the part I just talked about is a very small part of it. So data use agreements, they're very important. That's a DUA, and they're intended to ensure appropriate safeguarding and use of data. So data use agreements are legal agreements, right? And they're used between entities. So if I'm going to share data with somebody and I either buy or have access to data and I want to use it, then I have to sign an agreement with you, which really is very detailed. It talks about, what security requirements are for that data, what type of confidentiality requirements are done, and what conditions under which data may be accessed and disclosed. And this is important because a lot of this is private. So data is collected all over the place and for different reasons. And in healthcare, it's collected on your visits to the hospital. It's collected when you go to the clinic. It's collected when you fill out a survey online. It's collected when you're clicking on a website sometimes. But all that's private information. And you just can't use it for research or gain without some type of condition or anonymity. And public health has a lot of latitude as far as this goes. So we especially have to be very vigilant about what we do because we do work with entities that don't have that. So we have to be careful. And we have to ensure we have measures to ensure data tracking and use. So I have to know who's looking at what data and what they're doing with it. Again, I mentioned that example of the EHR, the electronic health record in hospitals. Health record access is monitored. As a matter of fact, all the clicks in there are monitored, and they're monitored for different reasons. But for the most part, they're monitored to see what you're doing in there. So is there a big brother in there? Yes, there is. And there needs to be. Because there are examples of people who used to abuse that. And I'll share one. That is, a famous person comes to your hospital. And, oh, wouldn't it be cool to see what they're in here for? And you look at their health record. Well, the hospital knows about it. And that's a reportable violation that costs the hospital thousands of dollars when it's discovered. So this is very serious. It's not something that's just taken very lightly. If you do something like that, you go to prison. It's not a simple thing. And you're fined thousands and thousands of dollars. So enforce compliance with the DUA. So DUAs usually have an enforcement clause in them that talks about what's going to happen. If there's a security breach, what is the procedure? So in my current position in the private firm I work for, I do a lot of work with the United States government and foreign governments too. And if we have a DUA with them, in which we do, it's very specific about what needs to happen and how we need to provide security for that data if it's moved around in our institution or even accessed through theirs. And also, what happens if there's a data breach? What needs to happen? What's the order? What do you do first, second, third, fourth? It's very strict. And those things all have to be followed. You have to provide evidence in the case of a security breach or unauthorized use of data. You can't hide it. You have to show it. You have to be able to show it. So I have to be able to show the people who own this data that I'm using that if there's a security breach, I have a way to prove that it happened. So people know, oop, somebody looked in there. What happened? What was the ramifications? And I think we've all seen emails and letters probably sometime in our lives that have to do with, oh, this website you signed up for had an intrusion or something, and you'll get free credit monitoring. But it's along the lines of, so data about data. This is metadata. This is really cool stuff. So metadata is structured information that facilitates usage and management, right, of important information resources. Metadata makes it easier to generate, not only easier to generate value from a resource, but enables you continued use of that resource by providing valuable descriptive information. So descriptive metadata is really important. It's got to do with sometimes it's an interview and words are used or things like that, but it also can do with other things too. So for this discussion, we're going to review three important divisions, right? So there's descriptive, structural, and administrative metadata. So let's just look at those now. So structural metadata, that describes the parts of compound objects, like the sections of a document, where things go, header, footer, that kind of stuff, right? Administrative data, metadata, is information for resource management. It's the creation of the database, dates, development platform, considered to be contents of the rights of the management of metadata, which is intellectual property rights, right? So we need to be careful about that. And the first one was descriptive data. I think I described it. I want to make sure I don't miss this, but it's the general context of the data, which can be used for discovery. So it's like identification, title, abstract, author. You've seen these before when you do lit researches, or in the future when you do it, you'll see them. So these are divided into three categories, which we talked about: format, vocabulary, and transmission. Okay, so we're going to talk a little bit more about them in depth. All right. So vocabulary and format standards. So in order for systems to be successful and communicate, there have to be both functional and semantic interoperability. So functional interoperability occurs when a system is able to physically communicate or share data. Okay. So you have to have this. So when you can functionally interoperate or physically communicate or share data, right, you need to have that. And semantic interoperability is the interpretation of data via a common language or vocabulary. So again, standards come into play here. How do we do that? Okay. So these are information exchange standards. So this has got to do with that type of data. So it defines the structures, the parts, defines the syntax. That's the arrangement, like, name. It would be like noun, verb, adjective, if you wanted to talk about, English language, but it's the arrangement of how you put it together, right? Of the electronic communication is referred to as the standards of sending and receiving information. And so Health Level 7, which is HL7, was created by developers in the 1980s. And in most hospital systems, it's been adopted by public health as the data format standard. It's a complex and flexible set of protocols that accommodates an enormous variety of. So vocabulary standards can either be local or universal. So both advantages and disadvantages for local and universal standards. So here's some examples. So one of them, a local code set may be more easily updated or changed by the source institution, but it may make data sharing with other institutions much more difficult. A universal code enhance data sharing between systems and across regions, but may require specialized training to use, and it may not be as flexible as local codes and adopting local circumstances. In other words, it might not have the flexibility of the verbiage to do a lot of descriptive things you might need in your code. So coding systems use clinical concepts or terms using unique codes and identifiers, and those are used in public health information, including laboratory data, syndromics, surveillance, and vital statistics. So let's talk about using as a primary example. Let's look at lab tests, lab results, and other subjects that also go with this. So there's other areas like specimen information, clinical findings, administrative or demographics. So let's look at the LONIC system. So this is a very widely adopted code system for laboratory observation coding in the United States. It uses terms which use 6 major components. There's a component, it's called an analyte. There's a kind of property. There's a time aspect. There's a system type. There's a scale. There's a method. And put all these together and you get a code. Now, you need at least the code, the analyte, property, timing, and scale to have a minimum data set. So some things aren't required, but you do have to have at least have these. All right. Take a look at one of these things. So bear with me. I know this is going to be new for a lot of you. We're like, what is that? So this is an example. 13203-5 is the Borrelia burgdorferi, which is a bacteria. So it's about an infection. So if I represent this in a LONIC code for a test, this is what I could get back for a result. And each one of these letters is a placeholder that represents one of the properties we just talked about. So let's break this down. So the component or analyte is actually the name of the bacterium. And that's what would go here, the AB.AGM. And that's what you see in this part here. That would be that piece of the code. Then the next part is the property. So that's the PRTHR. And that has the presence component and the threshold component. In other words, the presence, it's positive, negative, and how much of it do you have to have in order to say that. So that's also in here. Time aspect. So this is the point or time or a moment in time I collected it. And then the system type. So it's a sample type. In this case, it might have been cerebral spinal fluid. I pulled it out of a patient. So that's what this is saying, CSF. I need to know what is that. And then ordinal. So the scale is ordinal. Ordinal is qualitative, right? An ordered list of values. So it could be detected, not detected, positive, or negative. And that's what would fit in this space. And then the last one is the measurement method. How did I measure this, right? So what would that be? And that has to be with the technique or procedure I used to get it. So all of these things go together, right, to say how I end up with a code, right? So it's complex. That's not a very small string, but that string of information, this is a string. That's what this is called. All together makes a code set. And that tells me a lot of information. So what can I do with this thing? You can actually break that up into pieces and send it to different places when you need to, which we talked about before. So let's talk about SNOMED. So systematized nomenclature of medicine clinical terms. So this is really important. It talks about, it's comprehensive, it's a multilingual clinical terminology sort of dictionary. I think that's really a good way to put it. It's got over 3,500 terms in it and includes domains of clinical findings, disease, procedures, organisms, observable entities, drugs, vaccines, and medical devices, which means the list is growing because every day there's new drugs, new vaccines, and new medical devices. And of course, they have to be approved, but they enter that lexicon. It contains scientifically validated clinical content. It offers consistent representation of clinical content and EHRs. This is very important. So when I call something one thing, it's always the same. It uses descriptive logic in how it is. And that's what makes it a beautiful system. So it's easy to understand once you do it. There's other data coding standards. Those can include procedural technology. The current procedural technology code system. In 2006, the Geographic Names Information System was adopted. The Industry and Occupation Codes, the Standard Occupational Classification System, the North American Industrial Classification System, demographic codes, which also can be added on to that. And you can peruse those in your book. It's just the thing you need to take away from this is just an understanding that there are other code standards utilized in healthcare. And some of them may not seem like they have any direct relationship to healthcare, but they do in the public health domain. Okay, so future directions for this is that new technologies such as artificial intelligence, big data analytics, and biomedical ontologies will play an increasing important role in the delivery of healthcare. Artificial intelligence in processing and interpreting data health has already started to become important. An open biomedical ontologies program is an effort to create controlled vocabularies for shared use across different biological and medical domains. Very important. So now it's really trying to cross into both those domains so we use the same words. Standards will be as critical to these future efforts as they are in the present, which means they're not going away. we'll just have more of them or more precision in them. And so just one note I wanted to add on to this in closing, and that is, so there's a new, it's not that new, but it's newer for the world. Um, we use a system of codes for healthcare coding called ICD, and they are developed by the World Health Organization. And the United States just went on ICD-10 within the last couple of years. But several years before then, the World Health Organization released ICD-11, which is a much better descriptor group of disease and um, of morbidity and mortality. And it will be many, many years before the United States comes into that space, even though there are countries already now, Germany, etc. There's some other ones that are moving on to the 11th standard already. So as we move forward with standards, we're going to find early adopters and late adopters, which means being on a standard doesn't necessarily mean they're compatible. And that's a good example of that. And that's the end of the lecture for this week. I thank you.